right, once again we're finding the volume of a surface of revolution. So this time it's defined by this interesting equation, y minus 2 quantity squared equals 4 minus x, and the y-axis giving our region, and then rotating that around the x-axis. All right, now this graph is a parabola, okay, but it is a sideways parabola. If you plug in to find intercepts, okay, if you plug in x equals 0, you get that y is 0, okay, or you get that y is 4. We end up with two solutions from this. How am I seeing this? If you're trying to solve for the the y intercepts, since it needs to intersect the y-axis, I plug in x equals 0, so y minus 2 must be plus or minus 2. So y is 2 plus or minus 2, which gives me that 4 or 0 for my intersection points. Okay. Now, I want to rotate this around the x-axis. So this is my original region. Okay. When I rotate it around the x-axis, it's like it gets copied down to here, and we get a lovely bundt cake-like shape. Okay. Now, if I were going to do a method by washers, since this is my axis of rotation, I would chop perpendicular to that, and I'd get washers with a dx. I like dx. The problem is, of course, that washers would require these two things to be defined by different equations. So I actually can't do washer method with this one. So I will be doing a shell. Okay. Here is my shell slice. Okay, with a height right here and a radius right here. Okay. All right, so as is always the case, the volume of a slice with shells is 2 pi RH, and in this case, delta y. Okay, so radius. Radius is simply the y coordinate. I'll just write y for now. Height is the x coordinate. I'm just going to write x for now. I take a look at this and I realize I need to get rid of that x since I'm clearly going to be integrating in terms of y. So I'm going to go back to my equation, okay, down here, and I'm going to solve it for x. It tells me x must equal 4 minus y minus 2 quantity squared. Okay, you can actually FOIL this out, of course, to simplify it a little bit. That 4 cancels with that 4, and I get that x equals y squared minus 4y. I'm then going to plug this back into here. And again, distribute the y to simplify as much as I can before I get to my integral itself. Okay, so my volume is given by this integral. Once again, we need to be careful with the limits of integration. Okay, they are the furthest y coordinates from the original region, which is the black. So they are that 0 and 4 that I found earlier. Okay. So I take my antiderivative, plug in 0 and 4, and I get a volume of 128 pi over 3 for my bundt cake shape.